Applied maximum and minimum problem. In mathematical analysis, the maxima and minima of a function, known collectively as extrema, are the largest and smallest value of a function, either within a given range or on the entire domain of a function. Pierre de Fermat was one of the first mathematicians to propose a general technique, inequality, for finding the maxima and minima of functions. As defined in set theory, the maximum and minimum of a set are the greatest and least element in the set respectively. Unbounded, infinite sets such as the set of the numbers have no minimum or maximum. Number 1. The maximum or minimum over the entire function is called an absolute or global maximum or minimum. Number 2. There is only one global maximum and one global minimum, but there can be more than one local maximum or minimum. Functions can have hills and valleys, places where they reach a minimum or maximum value. It may not be the minimum or maximum for the whole function, but locally it is.
If the domain of a function for which an extremum is to be found consists itself of functions, in other words, if an extremum is to be found of a function, the extremum is found using the calculus of variations. Solving related rates problems. Step 1. Find the derivative. Step 2. Let the derivative equal to 0 and find the values of the variables. Step 3. Second derivative test. First, if second derivative greater than 0 equal to minimum value. Second, if second derivative less than 0 equal to maximum value.
Hazim has a large plot of land behind his house and wants to make it a place for gardening. Hazim subdivided half of the land with the rectangle shape that has 2000 meter square area to begin the planting. So, he wanted to make a brick wall and metal fence around the garden as a sign of division. The brick wall costing Rm 40 ringgit per meter, and on the other three sides by metal fence costing Rm 20 ringgit per meter.
Hello guys, today I will help my friend Hazim that has been facing a problem about how much cost that he need to buy the material for his garden. As we know, the brick wall costs 40 ringgit per meter, the metal fence 20 ringgit per meter, and the area for his garden is 2000 meter square. And the material cost we estimate as 50x plus 30,000x as our equation. The first thing we need to do is find the perimeter for the garden. 40x plus 20y plus 20x plus 20y equal to 60x plus 40y. The area for the garden is 2000 meters square. xy equal to 2000. Either we put y in front or x in front. For me, I will put y equal to 2000 over x. After that, 60x plus 40y equal to 40x plus 40 multiplies with 2000 divided by x. So the answer will be 60x plus 80,000 over x. I will use derivative method to solve the problem. Step 1 is find the derivative. 60x plus 80,000x the power of negative 1 equal to dc over dx equal to 60 minus with 80,000x the power of negative 2. Either you want to stop it right there, or you can do 60 minus with 80,000 divided by x the power of 2. It is very easy if you use 60 minus 80,000 divided by x the power of 2. Step 2 is let the derivative equal to 0. 60 minus with 80,000 divided by x the power of 2 equal to 0. Then 60 equal to 80,000 divided by x to the power of 2. After that, x to the power of 2 move to the front, so it will become 60x to the power of 2 equal to 80,000. Then 60 move to the back, so it will become x to the power of 2 equal to 80,000 divided by 60. X to the power of 2 equal to 1333.33. Then x equal to square root 1333.33, and the answer will be 36.51 meter. Next is type 3, second derivative test. We will use the first derivative that we have done, that is 60 minus with 80,000 divided by x to the power of 2. On the second derivative, it will become d to the power of 2 c divided by dx to the power of 2 equal to 0 plus 160,000 x to the power of negative 3. So we will convert it to the easy way, so it will become easy for us to calculate. So it will become 160,000 divided by x to the power of 3. The last step is when x equal to 36.51 meter. We will put it on the second derivative that we just got. D to the power of 2c divided with dx to the power of 2 equal to 160,000 divided by 36.51 to the power of 3, and the answer is 33.29. It is more than 0, so x equal to 36.51 meter is the minimum value. If the answer is below than 0, it will become maximum value. So that's how we know the maximum value or the maximum value. Next, we put the x equal to 36.51 meter on the first equation that we got, that is y equal to 2000 divided by 36.51. So the answer will be 75.44 meter. So the cost that Hazim need for the materials is 60 multiplies with 36.51 plus 80,000 divided by 36.51, and the cost will be Rm 4,381 ringgit and 80 cents. That is how much that Hazim need to buy the materials that he need for his garden. Okay, that's all for today. I hope it will help Hazim to solve his problem. Thank you.